Hello guys, in this video we are going to talk about the worksheet 10.1c level 2, which is a circle theory, the angles in the same segment. So to use this theory, you have to fulfill two conditions. The first one is going to be the angles on the circumference, and the second one is the angles watching the same arc. So for example, the both of x and y, they are on the circumference. So for this one, something like this angle and this angle cannot be used because this angle is on the circumference. However, for this one, it's not on the circumference, so it doesn't fulfill this, the first condition, so you can't use these angles in the same segment. So for the second condition, for this x is watching to this arc AB, isn't it? And for this y is watching to the arc AB as well. So both of them are watching to the same arc AB. If both of the condition is being fulfilled, then you can say that x is equal to y. The reason is the angles in the same segment. Okay, so for question 1, first of all, we're going to find the angle x. So the angle x is here. So let us see the angle x is watching to this arc CD. So is there any other angles are watching to this arc as well? So let's highlight this CD first, and then you can see from here, this CAD is watching to arc CD. So do this CBD is watching to arc CD as well. So now we can say that the second condition is fulfilled. So how about the first condition? Both x and b is on the circumference, isn't it? So that's the angle at the circumference. So both of the condition is being fulfilled. Then we can say that the angle x is equal to the angle CBD, and which is equal to 40 degrees. So for y, we can do the similar thing. The angle y is watching to the arc AB, is watching to the arc AB. And then to ask yourself if there's any other angle is watching to the arc AB as well. So we know that the y is watching to the arc AB. So do this angle x, the 45 degrees, is watching to the same arc as well. So now we can say that y is equal to the angle of ADB, which is equal to 45 degrees. And the reason to write in the bracket is the angles in the same segment. Okay, so that's for question 1. So now we can try to do the question 2. So for question 2, we actually have AB is intersect at E. So many students think that E is the center of the circle. However, as our questions doesn't say anything about the E is the circle, or there's no details about what is actually E, so you can't assume that it's a circle. I mean, you can't assume that it's the center of the circle, so you can't use any theory about the center. For example, the angle at the center twice the angle at circumference. So you need to try to use the other type of the theories. So first of all, if we look at our x here, the x is actually watching to which arc? It's watching to this arc AB. If we join this ADB, you can definitely see that the x is watching to this arc AB, isn't it? So is there any other angles is watching to this arc AB as well? If we join this AC together with BC, you can see that this angle is watching to the arc AB as well. So now you can say that the angle ACB is equal to x as well. So now we can write this something down. Angle ACB is this one. Angle ACB is equal to the angle of ADB. So now we have ACB is equal to ADB by using the angles in the same segment, and then which is going to be equal to x degrees as well. So after that, we can try to focus on this triangle, and we got a straight line. We produce another line from CE, and which is attached to A, and we can say this is the exterior angle of this triangle EBC, and so that we have the x plus x, we'll have this 102 degrees. So now we can say that the angle of ACB plus the angle of CBD, which is going to be equal to the angle of AEB. So as again, we have the angle of ACB and the angle of CBD, which adding together will give you the angle of AEB. So we change it back to the letters and numbers. We have x plus x give you 102 degrees. And then we solve for x is the x is going to be equal to 51 degrees. So that's for question 2. So now we can do question 3. First of all, we have the AC and BD intersect at E. And then we have the DB is perpendicular to AC. This DB is perpendicular to AC means that this angle, this angle, this angle, and this angle, both of these 4 angles are the right angles. And we have another angle is this angle CAD, which is equal to 25 degrees. So now we need to find out where is CBD. The question is asking about for CBD. So CBD is actually here. That's the angle we want to find. Sorry. So now we can say that this angle of CBD is actually watching to this arc CD, and this arc is watching by this 25 degrees as well. So now we can say that the angle of CBD, the required angle, is actually equal to 25 degrees by using the reason of angles in the same segment. So I say again, so this is our required angle. So this is watching to our arc CD, and this arc CD is being watched by this 25 degrees as well. So now we can say that the required angle is going to be equal to 25 degrees. So we can say that the angle of CBD, which is equal to the angle of CAD, and then by using the angles in the same segment, and then this is equal to 25 degrees. So now we have our required angle is equal to 25 degrees. And then for the part B, we want to find the angle of ACB. So this is our ACB. So ACB is going to be this angle. So this is our required angle. If we consider about the triangle EBC, then you can say that the 90 degrees is going to be our exterior angle, which is equal to the 2 interior angle plusing together. So now we can say that the 25 degrees plus the required angle ACB is going to be equal to 90 degrees. So the angle of ACB is equal to 65 degrees. So that's for question 3b, and we can try to do question 3c as well. So as before, we have this is equal to 25, and then this one is equal to 65. And so now we have one more condition, which is CB equal to CD. So CB equal to CD. So as we have 2 lengths are the same, if we concentrate on this rectangle, we can find that this is actually equal to 25 degrees as well. This is equal to 25 degrees as well, because by using the base angles isosceles triangle, we can say that this is 25 degrees as well. So now we have the 90 degrees here. We can try to find out what is the angle of ECD, which is going to be using the angle sum of triangle. 180 minus 25 minus 90 will give you 65 as well. Then because the question is asking, is there any angle have the same size of ACB? ACB is 65 degrees. Angle of DCA is equal to 65 degrees as well. So we find it out, the required angle is actually ACB. So first of all, we're going to write as the CD is equal to CB, so that we can have the triangle BCD is equal to 90 degrees. The triangle ACD is an isosceles triangle. So now we can say that as these two lengths are the same, so that the base angle are the same as well. So we can say that the angle of BDC is equal to the angle of DBC, which is going to be equal to 25 degrees. And then now we got this is 25, this is 90. Then by using the angle sum of triangle, you can find out this angle as well. So we have the angle of DCE plus the angle of BDC is going to be equal to 90 degrees. So now we can say that this angle plus this angle is going to be equal to angle 90. So that we have the angle of the DCE is going to be equal to the 90 minus 25, give you 65 degrees. So now we have the angle DCE is the same as the angle of the angle of ACB. So now we can say that this angle is actually the same as the original angle. So that's for question 3.